All right, so in this video, I'm going to walk through the problems of page 2 of the study guide for Unit 2. So problem number 4, we've got analyze the graphs of f of x. F of x is the blue curve, and g of x is the straight red line. It says sketch the graph of m of x equal to f of x times g of x. Now, initially you might look at this and say it's not possible because there's no numbers on this graph. But by analyzing your x-intercepts and your positives and negatives, you'll be able to graph this thing, at least sketch a graph. So first thing I want you to do is to mark the x-intercepts. So g of x, the red line, hits the x-axis right here, and f of x, the blue curve, hits right here at the origin, okay? Now, those 2 points are going to break up my overall graph into some sections. And so what I'm going to do is actually draw in a few dotted lines here where those x-intercepts are, just to really reinforce how it got broken up, okay? So when I look at the far left section over here, I've got the blue curve, f of x, is above the x-axis, which means it's positive. All right, so we've got positive. And I have the red line below the x-axis, which means its function values are negative. So when we take a positive number times a negative number, we will always end up with a negative, okay? Now, if I look between these two x-intercepts, the blue curve is above the x-axis, so it has positive function values, and the red line is above the x-axis, so it has positive function values. So a positive times a positive will always give me a positive value. All right. And then if I look at the far right side here, it's the exact same thing. The blue curve is above the line, that's positive. The red line is, the blue curve is above the x-axis. Let me say the right things. So the blue curve is positive, and the red line is above the x-axis, so it is also positive. So in the same way that last section was positive times positive, so is this one. So positive times positive still means that I'm going to have some kind of positive answers. So if I put this all together, what this tells me, this negative means that when I go to sketch my graph, I need to be below the x-axis. I'm going to go through the x-intercept. I need to be positive in this section, touch this x-intercept, and still be positive over here. So let's see if I can put that together into some kind of sketch. So we're going to start negative, go through the x, hold on one second, let me try this again. Start negative, go through the x-intercept, positive here, touch back to the x-intercept, and then positive again. Okay, now this might not be exactly how tall this part is. It might not be as steep. I'm not going to know that unless I actually know what f of x and g of x are to start with. This particular problem doesn't ask for it, but I tend to label the graphs just so I know what they all look like. And that was m of x. All right, so now I'm going to repeat the process and do the exact same thing for number 5. Now, number 5, we still have f of x and g of x. F of x is our blue line, g of x is our red line. And it says to sketch the graph of m of x equal to f of x times g of x. So same thing, we're just not going to end up with a third degree function, which was that first one was. What we will end up with here is probably some kind of a quadratic. So first things first, mark your x-intercepts, right? These 2 points are where those two functions are equal to 0. So if f of x here is anything and g of x is 0, well, 0 times that anything is still going to be 0. So it'll have the same x-intercept. The 0 here for f of x, right, that's when it hits the x-axis, the function value is 0. It doesn't matter what g of x is, 0 times anything is still 0. So those two x-intercepts would always stay the same if you are multiplying your functions together. Now I'm going to go ahead and draw in those nifty little vertical lines for myself just to separate up my graph. This way I'm not, I know exactly which sections I'm looking at to analyze. Okay, so far left section, the red line is below the x-axis, that's negative. The blue line is above the x-axis, that's positive. So a negative times a positive is going to be negative. All right, middle section here. Both lines are above the x-axis, so both lines are positive, which means we've got a positive times a positive. Well, that's going to give me a positive answer. Your far right side is going to be negative for the blue curve and positive for the red line. So we've got a negative times a positive, which means we would be negative. All right, so negative, positive, negative. Negative means I'm going to be below the x-axis here. I'm going to go through the x-intercept. Positive is above the x-axis, back through the x-intercept, and then negative down here. So let's draw in that little curve. So negative through the x-intercept, positive, back through the x-intercept, and then negative. So that's our m of x function for problem number 5. All right, so let me go ahead and label that. I'm going to go ahead and drop on down to number 6 here. All right, keep moving through this page. All right, consider the expressions. You've got x plus 2. We've got negative 4x minus 1 and 2x plus 3. Write a new function m of x, so m of x, that is the product of the three given expressions. If you don't know, product means to multiply. All right, so I want to show that I am multiplying these three expressions together. And so I'm going to show that multiplication with parentheses. All right, now it says to write the function m of x in standard form. Standard form means I need to multiply this out. So I am just going to multiply these first two expressions together. I'm going to ignore the 2x plus 3 for right now. So I'm going to take x plus 2 and distribute it. I'll clean it up as I go. So negative 4x squared. Let's see, minus x, minus 8x, minus 2. And that 2x plus 3 hasn't gone away. It's just I'm not going to deal with it yet. So let's see, m of x is equal to negative 4x squared minus 9x minus 2, 2x plus 3. Okay, so I have completely simplified these first two products, right? I multiplied the first two terms together, and now what I need to do is actually multiply with this 2x plus 3. Now, you can absolutely distribute like we did in the first part, and so that's what I'm going to do. I'm going to take 2x and distribute it times each one of these pieces. So negative 8x cubed minus 18x squared minus 4x. Now I'm going to take that exact same thing, but this time I'm going to distribute that positive 3. So negative 12x squared, negative 27x, and negative 6. All right, so all the multiplication is done in this problem. The last step here is going to be to combine some like terms. So let's see what we've got here. Negative 18x squared and negative 12x squared are like, and negative 4x and negative 27x are like. So let's go ahead and combine those up. That's going to be negative 30x squared, negative 31x, and then minus 6 at the end. All right. So Standard form means it's all multiplied out and it's in what's called descending order. So we've started with, whoops, try to grab this. There we go. All right, so our highest power of x comes first. So it's x to the third, then x squared, then your single x, and then you end with your constant or your no x term. Problem number 7 is going to ask you to do the exact same thing. All right, so let's see what our expressions are this time. So we've got 2x minus 1. We've got 3x plus 2. And then we have negative x plus 3. And in this case, we're writing a new function p of x. So p of x is equal to, and it says product again, so let's go ahead and show multiplication. So 2x minus 1, 3x plus 2, and negative x plus 3. And of course, it asks us to write it in standard form. Now, for this particular problem, I'm going to show the multiplication boxes. Some students like that, some don't. It's really up to you. So for the little boxes, I'm just going to multiply 2 at a time. So my first expression here is 2x minus 1. So that's going to split into 2 terms for the top. And then 3x plus 2 will split the side into 2 terms as well. And just like you did when you learned multiplication tables, we're going to multiply this top number times each of these side numbers, and then this top number times each of the side numbers to fill in the actual boxes. So 6x squared minus 3x plus 4x, and then minus 2. Now, what you can also do is immediately start looking for your like terms. So negative 3x and positive 4x are like. So when I go to write this out, I'll give myself a little space here. So p of x is equal to 6x squared plus 1x, or I'm just lazy and write x, and then minus 2. And then I need to take that times negative x plus 3. And remember, that negative x plus 3 came from the original problem up here. It's just we haven't used that part yet to multiply. So I'm going to go ahead and set up another multiplication box here. All right. And do the same kind of thing. So across the top, I've got 6x squared plus x minus 2. So each one of these is going to be its own little term. So that's 3 terms across the top. And the negative x plus 3 is 2 terms along the edge. So let's multiply this out. Negative 6x cubed minus x squared plus 2x. I'm going to multiply across now with positive 3. So positive 18x squared plus 3x minus 6. Let's look for some like terms. So negative x squared and positive 18x squared are like. And then we've got positive 2x and positive 3x are like. So if I put this all together, our p of x function is equal to negative 6x cubed plus 17x squared plus 5x minus 6. I'm going to box that up because we have completed our multiplication and it's in standard form. So if we look again, x cubed, x squared, x, and then there's the no x or your constant term. All right, 2 more quick questions here. Problem number 8 and number 9. All right, write an example of a cubic function with 3 distinct roots. Now, you get to pick what your roots are, and this is where this particular answer on my key will actually just say varies, because there's an infinite number of solutions here, okay? But if we go, let's say we want to write, c of x, I'm going to call it the cubic function, okay? And I need 3 distinct roots. All right, let's say I'm going to make those roots x is equal to 4, x is equal to negative 2, and x is equal to 17.6. It doesn't matter, okay? So each one of these answers, we're going to flip its sign when we go to write our factors. So if x is equal to 4, when we go to write the factor, that would become x minus 4. If x is equal to -2, we would have x plus 2 as a factor. And if x is equal to 17.6 or something else ridiculous, it doesn't matter, we would go x minus 17.6. All right. So your answer does not have to match this. These numbers are completely up to you. But because it says 3 distinct roots, those 3 numbers must be different. Okay, that's what the word distinct means. Distinct means different. All right, last problem on this page, and this is problem number 9. It says, write an example of a cubic function, all right, with one root that has multiplicity of 3. So you get to pick the root. I'm going to say x is equal to, 5, all right? But because it has multiplicity of 3, it actually means x is equal to 5 3 times, okay? So when we go to write this function, and it doesn't matter what you call it, I'm going to go g of x this time for giggles. If x is equal to a positive 5, the factor would be x minus 5. But because it shows up 3 times, I'm going to use the exponent of 3 to show it 3 times. You could also write g of x is equal to x minus 5 times x minus 5 times another x minus 5. And what you will notice when you do this is this number is the exact same thing as this number, is the exact same thing as that number. So that's where that multiplicity of 3 is coming from. Okay, so whichever way you want to write it, totally up to you. But because it said one root, each one of those factors has to have the exact same number in it. And we just happen to use it 3 times. All right, I'm going to close off this video, and there'll be 2 more for page 3 and then 1 for page